Okay, now let us take up the sense organ, very important sense organ, that is eye. Eye is important for the vision, as we know. Let's see what is the structure of eye, parts of the human eye we are going to study now. And then we'll know about how actually the vision is brought about. We have a pair of eyes located in the cavities of our skull called as orbits. So, in the orbits, the eyeballs are located. We have a pair of eyes which are located in front of our face, and so that we have a binocular vision. In some other mammals, almost all other mammals except primates, you see that the eyes are on the sides. Most of the animals have the eyes on the sides. So they can see, for example, the right eye can see the right side vision only, whereas the left eye can see whatever is there on the left side. So that is monocular vision. But we have got binocular vision. Both the eyes will focus on the same things, and both the eyes, whatever they are taking the images, they will be merged together to make a very perfect vision. So we have a binocular type of eyes. Now this diagram gives you an idea about how the eyeball looks in a section. It's almost spherical in structure. Eyeball has got a thick wall which is made up of 3 layers: sclera, choroid and retina. Sclera is the outermost tough covering which is made up of mainly collagen fibers. Tough collagen fibers make up the hard outer covering. The white part of the eye, what you see, is actually the sclera. And this sclera in the front, in a circular region where it is slightly bulging out, and it is thin in this region and transparent. And that transparent window is called as cornea. The transparent window is called as cornea, which is from here to here. And that is the circular spot what we see, the black spot. It appears black because through this transparent cornea we are actually looking at the pigmented part of our eye, that is iris. Okay, so this is the cornea, which is called as a front window, which allows the sunlight to pass through. Okay, any light to pass through it. It is transparent. Then the next layer is below the sclera is choroid. Choroid is a layer which is highly vascularized. So vascular layer we call. What does it mean? So it contains blood vessels. So it carries the nutrients and oxygen through the blood to all parts of the eye. And this choroid layer is thin in much of the posterior part of it, and anteriorly it becomes thick and it forms what is called as ciliary body and iris. This choroid layer is a pigmented layer. It's also pigmented layer. So it is darker. And as it is having the pigments, it will not allow the sunlight to enter inside, so it will be blocking the sunlight in this region. This iris in front, which is a part of the choroid, is disc-like actually, and has got an opening in the center that is called as pupil. So this opening is actually pupil from here to here. and that is the small darker spot you see in your black part of the eye, which is actually an opening in the center of this iris, through which actually the light is falling onto the lens and passing through the lens. Okay, so that's called as a pupil, and these two structures which are coming cross section, thin disc-like structure it is, and that is called as iris. I have drawn the picture of iris over here, and this opening in the center is called as pupil. We'll come back to that diagram when we take up the accommodation of light. Now let's first understand the structure of the eye. So we have seen iris, pupil, and then this is the ciliary body. Ciliary body performs important function. It allows the connection of the lens with it by the help of suspensory ligaments. So that means this ciliary body, which is a muscular tissue which contains circular muscles, this is connected to the lens by suspensory ligaments. And these suspensory ligament and the ciliary body, they are important for the focusing of the image, changing the shape and thickness of the lens. So that's called as accommodation of lens. We'll come back to it later on. So this is the ciliary body we have seen, which is thick in the front but becomes thin as we go posteriorly. Okay, and that ciliary body continues as what? Here, that is the second layer, choroid. Clear? So now the third layer is called as the retina, which is very important layer of the eye, which is covering the inner surface of the eyeball. That's about 2/3 of the posterior part of the eyeball is covered by the retina. Retina is a nervous or neural tissue. It contains the photoreceptors and the neurons. So therefore it is photosensitive layer. Photosensitive layer, and it contains the photoreceptors. It is the main layer of the eye which is helping us in seeing the things around. Okay, now this retina, which is having one region which is exactly in line with the lens and the pupil, and that circular part here, if you take up of the retina, which is yellow in color, it is called as macula lutea. And in the center of the macula lutea, what we see is this layer has become thin, as you can see here in a section, as we see here, it has become thin by this notch. So this thinned out part is called as fovea. Fovea and macula lutea, these are helping us in making the perfect vision of any object we are focusing on. Okay? Now from the retina, large number of the sensory nerves arise, and all these sensory nerves together will make up what is called as the optic nerve, and that carries the sensory signals from these photoreceptors in the retina. Whatever the signals are generated, those are carried by these sensory nerves, sensory neurons through the optic nerve, and that's how the signal or the message is conveyed to the central nervous system. So that's about the three different layers of the eyeball. Now eyeball as such is divided into two chambers. The front chamber, what you see here, between the lens and the cornea, and of course the cornea is covered by a protective thin membrane which is called as conjunctiva, which is also transparent. That's a protective covering in the front exposed part of the eyeball. Okay. Now we are talking about the chambers of the eye. There are two chambers. One is the aqueous chamber in between the cornea and the lens, and another is vitreous chamber, that is between the lens and the retina. Vitreous chamber is the largest part of the largest chamber, you can say, which is filled with a vitreous humor, which is filled with vitreous humor, a gel-like substance inside, and that helps in maintaining the spherical shape of the eyeball. Shape and size of the eyeball is maintained by the vitreous humor, which is filling the vitreous chamber. And in the aqueous chamber there will be watery liquid which helps in providing the nutrition and oxygen to this part of the eye. And this liquid always keeps changing. It is drained and again refilled continuously. So that is the aqueous chamber containing the aqueous humor. It contains aqueous humor, we call. Now lens is located just behind the iris. It is transparent glassy structure, circular in shape, and this lens is responsible for focusing the image onto the retina. And always remember that the object what we see, its image will be inverted when it falls onto the retina, and it is again corrected by the central nervous system and by the optic lobes, and then the central nervous system where we have the vision center. So there actually the real image of the object is seen. Now that means eyes are just working like camera, and the man behind who can see and identify the things is our brain. Now that is about the structure of the eye. Some more information we can get from this diagram, like lacrimal gland which secretes the tears that keep our eyes wet, and then also meibomian gland which is there in the eyelids, and this also secretes one oily liquid which will prevent the evaporation of the tears and keep our eyes shiny and protect the eyes, especially the exposed part of the eye, right? And which is always kept shiny and wet because of these two glands. And whenever we are emotionally excited, the lacrimal gland secretes a lot of the liquid that comes out as tears. Okay. Now, if you look at the functional part of the eye, let's take up first iris, a circular disc in front, which is a part of the pigmented layer, choroid. Okay, and it contains a lot of pigments inside. So it is the dark pigmented layer, and these pigments differ from person to person. In India, we usually have the iris color, which gives color to our eye, like dark brown, honey color, or blackish eyes we have. But in Western countries, the pigment may be of blue color, so blue eyes you might have seen. Some have blue eyes or grey eyes. So that's all because of the color pigment present in the chloride, and that is seen in the iris. I have told you one function of the iris is to prevent excess entry of the radiations inside the eyeball. It has got the opening or aperture in the center called as a pupil, and size of the pupil can be adjusted by the iris. So it is helping in making the pupil, this aperture, narrow or wide as and when required. Now if you look at the structure of the iris, inside the iris we have two types of smooth muscles. Radial muscles, which are arranged in radiating fashion, and circular muscles in the form of rings around the pupil, extending up to the extent of the iris, right? And these two muscles play a very important role in changing the size of the pupil. For example, we are looking at a very bright light or seeing some object in a bright light. At that time, the light reflecting from the object, that will be intense light, more light is entering. So to see that excessive light should not cause damage to our retina, the pupil size will be made narrow. So when we see the things in bright light, what happens? Pupil becomes narrow. And how does it happen? Let's say, to make the pupil narrow, the circular muscles undergo contraction. Circular muscles of the iris contract, and the radial muscles relax. So that means as the circular muscles contract, they come more closer, okay? The width of this iris, or the diameter, it increases, and the diameter of the pupil will decrease, and that is how the pupil becomes smaller, preventing limited amount of light to enter inside. So that is when we are looking at the object in bright light. Now what happens if we observe any object in the dim light, especially when you enter into a dark room, or when you enter into a theater, cinema theater, where there are no lights? So for a few seconds you see nothing actually, because your eyes have to be set for the dim light, and even the pupil size also has to change. Now as there is a less light, so to allow enough light to enter so that we can see the image, the pupil has to become larger. So widening of the pupil takes place. Now let us see what happens. In dim light now, or in less light, the pupil becomes larger. So what happens? Pupil dilates, because dilates or widens. How does this happen? Let us see. Now here what happens is, the circular muscles of iris relax. Circular muscles of iris relax, they go away from the center, and then the radial muscles contract. So they become short by contracting. So as a result, what happens is the pupil size increases, pupil widens. So that is how the light is accommodated. So what we have understood now from this is, it is the accommodation of light. How much amount of light should enter into the eyes is decided by, or is adjusted by the muscles of the iris. Okay. Now let us take up another factor, another aspect, that is about the accommodation of lens. So till now we have seen accommodation of light, which is brought about by the muscles of the iris, and now accommodation of lens. Now this is the lens, what you see in the center, and this is the ciliary body surrounding it, which is also having the circular muscles inside, circular muscles, okay, and ciliary body is connected to the lens by the suspensory ligaments. Suspensory ligaments. Okay. Now, when we are looking at the closer object, when we are looking at a closer object or nearby object, what happens is, this diagram shows you the changes in the lens and the ciliary body when you are looking at nearby object. To focus on nearby object, the lens in cross section, if you see, becomes thick and short. The lens becomes thick and short, as we see in cross section here. This is a three-dimensional wave I have drawn. So what is happening here is actually the circular muscles in the ciliary body, they undergo contractions. So we can say ciliary muscles contract, okay, come closer to the lens, and thereby the ligaments get slackened, means they become loose, as we see here. So that they are not stretched. So the tension on the lens is relieved. There is no tension on the lens, so lens becomes more thicker and shorter. So that's what we see here. The height of the lens is reduced and its width or diameter or its thickness, you can say, has increased. So we say that the lens becomes thick and short, so that we see the nearby object. Now what happens when we look at far away object? Let us see. Now when we are looking at far away object, again the shape of the lens and its thickness has to change. So I will rub this one. We'll look into the another diagram I have drawn there. So this diagram gives you the changes in the lens and the ciliary body when we are looking at far away object. So what are the changes happening here? Ciliary muscles relax. So we see that the ciliary body moves away from the lens like this, right? Its diameter increases. So what happens is ciliary muscles relax, they move away from the lens, and that's why what happens is the ligaments get stretched. So because they are pulled apart, pulled or stretched out, so that's why they are called, the ligaments get stretched. So as a result, when the ligaments are stretching and becoming straight, so they pull the lens from all the sides. So when the lens is pulled from all the sides, so lens becomes both thin and long, we say, in cross section. See, its length has increased and it has become very thin. So that is how the accommodation of lens takes place, so that we are able to see both near object and far object by this adjustment. So with this we have learnt about the structure of the eye. We'll take up next the vision, how actually the vision is brought about, the mechanism of vision we'll take up in next video.